Hello everyone, welcome to the channel uLearn Education Online. In the previous video, we understand how to design an inverting amplifier circuit using op-amp, and also we came to see the definitions of a sign changer and also the inverting amplifier of op-amp, and also we came to know how to derive the output voltage in terms of input voltage for the inverting amplifier circuit. Now, in today's video, let us discuss how to design a non-inverting amplifier using op-amp circuit, and also we are assuming an ideal op-amp, and hence in an ideal op-amp case, how to derive the output voltage in terms of input voltage we are going to see. Now, let us discuss what is a non-inverting amplifier. This non-inverting is nothing but when an input signal is applied to the non-inverting terminal of op-amp, we can say that this op-amp is non-inverting op-amp. And here, what do you mean by this amplifier? This amplifier is used in order to increase the incoming signal strength. Okay, so when the op-amp is activated in amplifier circuit, or we can say that when the op-amp acts as an amplifier, even if the input is applied to the non-inverting terminal, we can say that the op-amp has a non-inverting amplifier. So, according to the definition, this op-amp will amplify the input signal and it will produce the output signal which has a phase shift of 0 degrees or 360 degrees with respect to the input. For example, if you consider the input signal is a sinusoidal signal. Okay, now the output of a non-inverting amplifier is also a sinusoidal signal with a 0 degrees phase shift with respect to the input signal, which means that there is no change in the shape of a signal. Okay, if you consider the other case, that is, if it is started with like this, then the output of a non-inverting amplifier circuit will be like this. So from this we can say that there exists a 0 degrees or 360 degrees phase shift between the input and output signal. Okay, now let us discuss what is the circuit of a non-inverting amplifier circuit. So as we can say that whenever the input is applied to the non-inverting terminal and this op-amp, if it acts as an amplifier circuit, we can say that this total circuit is a non-inverting amplifier circuit. Now let us derive the output voltage expression in terms of input voltage. Assume this op-amp is in ideal case. Okay, if the op-amp is in ideal case, we can say that the virtual ground concept is applied. Okay, now what do you mean by virtual ground concept? The voltage at the inverting terminal of op-amp is always equal to the voltage at positive terminal of op-amp. Indeed, the difference voltage between the two terminals are 0 and the currents entering at the inverting terminal and non-inverting terminal of op-amp is 0. Okay, so from the circuit we can say that the node B voltage is connected to Vi, which is the non-inverting terminal voltage. Okay, and the node A is connected to the negative terminal of voltage. Since Vd is equal to 0, we can say that Vb minus Va is equal to 0 implies Va is equal to Vb. Since Vb is input signal, unintentionally the node voltage at A point is connected to Vi. Okay, now apply the nodal analysis at node A. So if you apply nodal analysis at node A, we get Va minus 0 by R1 plus Va minus V0 by Rf is equal to 0. Since Va is equal to Vi, now substitute this in the above equation, we get Vi by R1 plus Vi minus V naught by Rf is equal to 0. Now common Vi, we get 1 by R1 plus 1 by Rf is equal to V naught by Rf. Now here let us take LCM. So V naught by Rf is equal to Vi into Rf plus R1 by R1 Rf gets cancelled. So finally the Vi into R1 plus Rf by R1, or we can say that the value of V0 is Vi into split the LCM R1 plus R1 by Rf plus R1. So here the V0 value will be equal to Vi into 1 plus Rf by R1. Okay, this 1 plus Rf by R1 we can call it as an amplification factor or gain of non-inverting amplifier circuit. So this is how to derive the output voltage of a non-inverting amplifier circuit with respect to the input. Okay, if you really think that video is useful, please like, share and subscribe our channel.